Okay, good day. Today we're looking at the power of a test and type 2 errors. This is the completion of section 9.1 from the textbook. So I'd like you to recall that if we reject the null hypothesis when it is actually true, we have committed a type 1 error. And if we fail to reject the null hypothesis when it is false, we have committed a type 2 error. And so you'll recall from class we had this little graphic. If a person is going in for a pregnancy test, the null hypothesis that they are not pregnant, in other words, that's the status quo, and the alternative hypothesis is that they are not pregnant, therefore pregnant. So type 1 error is false positive, telling a person they are pregnant when they are not. In other words, rejecting the null hypothesis when it is actually correct. Type 2 error, false negative, is not rejecting the null hypothesis when it is no longer valid. So telling a very pregnant, an obviously pregnant person that they are not pregnant is one example of that. All right, back to our lesson. For example, the Department of Health plans to test the lead level in a public park. The park will be closed if the lead level exceeds the allowed limit. Otherwise, it will be kept open. The department conducts the test using soil samples gathered at randomly selected locations. Which type of the following decisions would be considered as making a type 1 error in this situation? So go and read them yourself. Okay, so we'll look at each one individually. Keeping the park open. Oh, before we look at that, let's look at what is our null hypothesis. And so the null hypothesis in this case, we are looking at the lead levels being okay. And the alternative hypothesis is the lead levels are not okay. In other words, in this case, they would have to be too high as opposed to too low. So keeping the park open when the average lead levels exceed the allowed limit. So if they exceed the allowed limit, the null hypothesis is false. And so this is what we would call a type 2 error. Okay. If the lead levels exceed the limit, what we want to do is to close the park, and so keeping it open is an error. B, closing the park when the average lead level is acceptable. This is HO is true, and yet we've closed the park. We want to be able to keep the park open as much as possible, so this is our type 1 error. Okay, so that one is our correct answer. Let's look at C anyways. Closing the park when the average lead level exceeds the allowed limit. This is what we want to be able to do. Okay, we want to detect and close when necessary. So that's what we're aiming at. And that's what our power is, what power is looking at is the power to be able to detect when our null hypothesis is false and be able to deal with the situation. So let's look at the probabilities of making each kind of error. Rejecting HO when HO is true is what we call a type 1 error. And so the probability of a type 1 error is alpha. And that is what we call the significance level. And so we're just going to look at the first column for now. Failure to reject the null hypothesis would come with a correct conclusion, and the probability is going to be 1 minus alpha. When we look at those situations, we're looking at the distribution of having HO being our mean, or our proportion, whatever we're looking at. And we would look at a Z value that gave us the alpha being the area, the probability of having Z or greater in this case. Okay. If H naught is false, and there is an alternative hypothesis, so if we choose an alternative hypothesis that is the correct one, now if we reject the null hypothesis, when it is false, that's the correct conclusion. If we fail to reject the null hypothesis when it is false, we have made a type 2 error. So the probability of a type 2 error is going to be labeled beta. And so beta is the probability of rejecting, of not rejecting a hypothesis that is false when another hypothesis is true. And so if HA is true, what we would actually be looking at is the distribution for HA. So I'm going to put a little knot there. So if HA were true, let's say HA is higher than H naught, what we're going to look at in our, we'll have a simulation in a little bit, but if that is our Z value on our new graph, the probability of making that type 2 error is beta. So it's based on HA rather than H naught because HA is what is actually true. Now, let's go back up to our top right square. If HA is true and HO is false, we want to reject HO, and that's a correct conclusion. So the probability of this is going to be 1 minus beta. In other words, all of this other area that I'll color in red, okay, that is, I'll just keep that color for now. That is what we call our power, and it's 1 minus beta essentially. Okay, it's related to that. So it's the strength of being able to make the right decision given that our null hypothesis is false, and given that we know we have an alternative hypothesis that ends up being correct. So to summarize that, the power of a test we can think of as how strong it is, in other words, the probability of so how strong it is at detecting that H naught is false when a specified alternative is true. Okay, so when H naught is false and we have rejected it, we've made the right decision. We've made the correct decision then. Our ability to detect a type 2 error is called the power of a test. When the null hypothesis is actually false, we hope our test is strong enough to reject it. And beta is the probability of failing to reject not a false positive, but a false null hypothesis. Okay, so that was, zipping back up here, failing to detect the correct alternative hypothesis, or failing to reject the false null hypothesis. So therefore the power of the test is 1 minus beta. So I've added in that right now we're going to investigate with an applet. So you can follow along with me, and then you can try it out yourself later on.